Welcome back to part 2 of section 412. So as we discussed in the last video, we talked about the value of A. When A is less than 0, x-axis reflection. When the absolute value of A is greater than 1, there's a vertical stretch. And when the absolute value of A is between 0 and 1, there's a compression. Now, the reason we're looking at the absolute value is it doesn't matter for stretch or compression if A is positive or negative. The negative value of A just tells us that there's going to be a reflection. So looking at all of these, they would all have the same vertex. The vertex for every one of these is going to be at 0, 0. And so is the axis of symmetry. That's going to be at 0, 0 as well, x equals 0. Now, for x squared, we actually call this our parent function. This is the basis of all of these graphs. There's y equals x squared. That's the basic shape of all of these parabolas. Now with 4x squared, because that leading coefficient is a 4, there's going to be a stretch, a vertical stretch. We'll still start at the same vertex. And then our points would be here. You can see how much narrower that is. There's that vertical stretch, in action. Now for 1/2 x squared, that's going to cause a compression. So our graph would be kind of pressed down. It's wider. And now for negative 2x squared, that's going to have a stretch, as well as it's going to be reflected along that x-axis. So the vertex is still there. So there's y equals negative 2x squared, and the negative 1/3 x squared is going to be wider. It's going to have that compression to it. And there's all of our different graphs. I know the graph is a little messy, but that's what there's going to happen. You can see the parent function, vertical stretch, vertical compression, x-axis reflection and a stretch, x-axis reflection and a compression. Now, looking at the graph for problem number 8, x squared minus 5. You could use your calculator to graph this. We're at 0, negative 5. And our graph is going to look like this. You can see now our vertex is at 0, negative 5. And our axis of symmetry, x equals 0. It always goes to the x coordinate of the vertex. Next page, x squared plus 3. Now our graph, when you use your calculators to graph it for right now, it's going to look like that. So you can see now our vertex is at 0, 3, and the axis of symmetry, just like the last one, x equals 0. Now that's going to help us here with the general form of a quadratic. Y equals A times the quantity of x minus h squared plus k. So this we call the vertex form or the graphing form. The reason we do that is our vertex is given to us in this form. The vertex is at h and k. Be very careful with your value for h because it's x minus. You always want to take the opposite of what you see for h. So we'll point that out as we go through the next ones. And now the vertex is at hk. Now, what these values do, when a is less than 0, as we talked about, there's an x-axis reflection. When the absolute value of a is greater than 1, that's when we have a vertical stretch. That's when our graph is narrower. When the absolute value of a is between 0 and 1, we have a vertical compression. That makes the graph wider. And now these h and k's. H, we're shifting left if it's a negative and right if it's a positive. K, we shift down if it's a negative and up if it's a positive. Now, we're going to graph the next few without a calculator. And it's all by using our shifts. Now, our anchor points, these are the basic points we use for every quadratic. -3, -2, -1, 0, 1, 2, 3. So all you're doing is you're squaring it. So it's 9, 4, 1, 0, 1, 4, 9. Those are our anchor points. So now, using our anchor points, I'm going to first start by plotting my anchor points. 0, 0, 1, 1, 2, 4, 3, 9, -3, 9, -2, 4, -1, 1. Now, A is -1/2. H, it's the opposite. It's a -4. And K is 3. So I know right away the vertex is at -4, 3. I know my axis of symmetry, x equals -4. So what I'm going to do, this is going to be an x-axis reflection. And a vertical compression. So I'm going to reflect them first. So to do that, I multiply all of my y's by -1. 0 times -1 is 0. The y value is 1 times -1 is -1. The y value is 1 times -1 is -1. We're at 2, 4. The y is 4, so times -1 is -4. Same thing here. We're at 9 times -1 is -9. There's my reflection. That's taken care of. And now I have to compress them. To do that, I multiply my output, my y value again, by 1/2. 0 times 1/2 is 0. -1 times 1/2 is -1/2. I'm using open dots here. 4 times -1/2, -2. -9 times -1/2 is -4 1/2. So through those little open dots is where we're going to draw our points. And now we're going to go to the left 4 and up 3. So I take each point and go to the left 4 and up 3. to the left 4, and up 3. To the left 4, and up 3. To the left 4, and up 3. And then we can draw our graph through those points. I know it's a little tricky, but I'll show you another way to do it on the next one, where we can condense the reflection and compression. But that's our graph. That is what our graph looks like. And I didn't do a very good job of drawing it. It's just a really rough sketch. And there is our graph. For 11, I'm going to start by plotting my anchor points. 0, 0, 1, 1, 2, 4, 3, 9, negative 1, 1, negative 2, 4, negative 3, 9. Now A is 3, H is a positive 5 this time. Remember, change the sign for H. And K is negative 3. So what we have here is we have a vertical stretch. And we're going to go to the right 5. And then we're going to go down 3. So for the vertical stretch, we're going to multiply our y value, the output, by 3. 0 times 3 is 0. 1 times 3 is 3. Same thing here. 4 times 3 is 12, so it's off the graph. I'm not even going to worry about the other points. And now those stretch points, I'm going to move them to the right 5 and down 3. So each point, I'm going to go to the right 5, down 3. To the right, down 3. To the right 5, down 3. To the right 5, down 3. And there's my graph. It's something we're going to have to be working on and practicing, but there is the graph without using a calculator. For the final few, we're going to be writing equations. Now it tells us it's vertically compressed by 1/3. So remember, y equals a times the quantity of x minus h squared plus k. So that is our value for a. A is 1/3. We're going to the left 7. So h is negative 7 because it's to the left. And k is up 10, so it's a positive 10. So y equals 1/3 x minus negative 7 squared plus 10. So y equals 1/3 the quantity of x plus 7 squared plus 10. Another one here, it's vertically stretched by 5 and reflected along the x-axis. So A stretched 5, so it's a 5, and now reflected, so it's a negative 5. H, we're going to the right 2, so H is 2. K, we're going down 4, so it's a negative 4. So y equals a x minus h squared plus k. So y equals negative 5 x minus 2 squared minus 4. So for number 14, we're compressed by 1/5 and reflected along the x-axis. So A is not just 1/5. There's our compression, but the reflection, it's a negative. H, we're going to the left 12, so H is a negative 12. And we're going down 2, so K is a negative 2. So y equals a negative 1/5 x minus negative 12 squared plus negative 2. So we clean that up. Y equals negative 1/5 x plus 12 squared minus 2. There's our equation. It's going to take some time to get used to it. Like everything else, the more we practice it, the easier it gets. And we're going to be doing more practice of this in the next section. Thank you.